All right, so we are moving on from multiplying and dividing, and now we're going to do adding and subtracting. Going back to the basics. Take it out, James. I'm sure you know what that means. Okay, so let's go to the basics of 1/5 plus 2/5. I said when you're adding and subtracting to think of like terms, but with fractions we want to think of like sizes. So are fifths the same as fifths? Then can you add them? Yes. How many fifths will there be?
3.
3/5. So to recap, did I change my denominator at all? No, because it was the same size. We just wanted to know how many shaded pieces there were in total, which was 3. Does 3 and 5 have a common factor we can divide out?
No.
Nope, then we're done there. Okay, then what about the next one? 1/5 plus 3/10. Are fifths the same sizes as tenths?
No.
Then you're not allowed to add them. So I need to find a missing factor. What does factor mean again? What are factors? What are factors? Numbers that you multiply, right? So then if I want to find a missing factor, which of these numbers is missing something? The 5 or the 10?
5.
The 5. What factor is missing here in order to get 10? 2. Because 5 times 2 is 10. But remember when we drew our pizzas and we said, okay, if I cut my pizza up in a bunch of slices, like let's say I have 1/2. Here's a half, right? And I want to cut it up into 4s. Can we still say that there's 1 out of 4? No. So what you do to the bottom of a fraction,
We already did this.
you also have to do to the top. I know, that's why it says recap or recall, whatever. All right, so now what does this give us? 1/5 is the same as 2/10 plus 3/10, and now we can add them to each other. 2/10 and 3/10 is? Are there any common factors that 5 and 10 share? 5. So we could divide out a 5, and it reduces to 1/2. The reason we're doing this is because the same thing I'm explaining is what I'm going to explain when we get to these down here. Okay, so the next one we have 1/5 plus 2/3. Are fifths the same sizes as thirds? Then we need to make them the same. So can I multiply 3 by some factor to get 5?
No.
Can I multiply 5 by some factor to get 3?
No.
So then how do I get the denominators the same?
Multiply by 3 and 5.
By each other. So 3 is missing the 5, and 5 is missing the 3. But again, if we multiply the denominator, we also multiply the numerator. And now let's rewrite. 1/5 is the same as 3/15. 2/3 is the same as 10/15. And now when I add them, since they're the same sizes, we get 13/15. Do those have any common factors to divide out? No. So then 13 over 15 stays
Can I question?
when Julie gets back. Okay, so we're going to go through the steps really quick of what we just said. One thing that's not going to go away is the fact that we have to factor expressions. We're still going to have to factor in order to simplify and things. But when we're adding and subtracting, do I focus on the numerators right away? No, what do I focus on? Denominators. So then the first step you want to do when you have expressions of rationals is focus on your denominators and make sure that you factored them. Because when the denominators are written in their factored form, it makes it easier for us to find a common denominator. All right? So let's look at example 1, for instance. Are the denominators factored? No, but we do notice that they are a equals 1 and what else do you notice? They're already the same. So let's do step 1 really quick, and we're going to fill in these steps as we go. So step 1 is factor the denominator. So let's use our a equals 1 rule. So our shortcut, we're going to expand. A times c is?
2.
My b value is?
3.
So what factors of 2 will add to give you 3?
1 and 2.
So then using our shortcut, we know that we're going to have how many x's in each of these factors to give me x squared? 1, because x times x is x squared. And then what numbers multiply to give you the 2? Plus 1 and... So we're going to replace this with its factor form. Let's rewrite. So cross this off, put x plus 1, x plus 2. This one's exactly the same thing. X plus 1, x plus 2. So step 1 is done. We factored the denominators. Any question? Okay, well then step 2 is we want to compare the least common denominator. What it means is just compare them, and you want to multiply it by something as small as possible. You don't want to change them by multiplying exactly by each other if you don't have to, because you're making it more complicated. But we already know that these are the same. So am I missing any factors? No, we're not. We don't have to multiply by anything. But what if I needed to? Let's look at example 2. 8 and 8x, they don't need to be factored. That's why I'm kind of doing both of these. What is 8 missing as a factor? That needs to be 8x. It's missing an x. So then in step 2, if we know 8 is missing an x, we need to multiply the denominator, but also the numerator by x. So let's go fill that in. In step 2, if you're comparing them and they're the same, you don't need to multiply by anything. If you're comparing them and you're missing a factor, you need to multiply by the denominator and the numerator. So question on step 1 or step 2?
1.
Step 1, we just factored our denominators because we know that that's easier to work with. We used our a equals 1 rule, but you weren't in here. All right, so now we're on step 3. We'll go back to example 1 to finish it off. We want to combine the what? So once we had our common denominators, what did we add? We add the numerators together, but what do we do with the denominator? Leave it the same. So then let's fill this in. We will combine the numerators, but keep the same denominator. So it is not like multiplication where you attach them. I don't know what we're doing on calculators. Let's go. What? All right, so then if I'm combining the numerators, I want you to look closely. What is my common denominator right now? If I want to combine these into one fraction, what's my common denominator? X plus 1 times x plus 2. But I want to combine the numerators with each other. Are these adding? Are these adding? They're what? Subtracting. So then I want you to read to me. What is it I am subtracting? Read it off. You're subtracting.
3x minus 4.
So then is it just minus 3x?
No.
It's minus all of it. So think about it as bringing in that negative to everything. Okay, so let's write what we have at first. We started with 7x plus 4, and then we're subtracting 3x, so we put minus 3x, and we're subtracting what number?
4.
Huh? We're subtracting negative 4. But what happens when you subtract a negative? It turns into positive 4 because that's a double negative happening. Question right there. Did I lose anybody with the double negative? Okay, so is my numerator fully combined right now? Fully combined? What else can you combine? The x's and the 4's. So 7x minus 3x is?
4x.
And 4 plus 4 is? 8 over the same denominator. Okay, so we're done with step 3. We're on the very last step. What does step 4 say? We're going to factor if possible because sometimes they're not factorable, right? Why are we factoring it? Because we can simplify it, just like with multiplying and dividing. You want to factor and simplify, right? So can my numerator be factored? Yes. What does the 4 and 8 share? 4. So let's divide out of 4. And we have what remaining? X plus 2. 4x divided by 4 is x. 8 divided by 4 is 2. Over the same denominator, x plus 1, x plus 2. So does it simplify? Do we have any common factors that we can divide out? Now we're done. Okay, questions on example 1. It's similar, yes, but not completely the same because did we get common denominators for multiplying? No. Am I attaching the denominators for adding? So that's the difference right there. It's all through the denominators. We're not multiplying, we're dividing. But they still do share the simplifying piece of factoring, yes. All right, so example 2, let's finish this one off. We multiplied by x, right? So right now we were on step 2. We found our common denominator. So step 3 says what? Combine them. Okay, so what is my denominator? 8x. And we want to combine the numerators. So x times 5 is 5x. And we're subtracting 3. Okay, then step 4 says factor the numerator if possible. Can I factor the numerator? 5 and 3 don't have any common factors, and there's no exponents, so you're done. Why am I not allowed to cross these x's off? This one's not attached to everything. You can only cross off factors, not things that are adding.
So you only have to make this denominator equal.
Yes, you have to make common denominators, just like how we did up here at the beginning. We have to have common denominators before adding. All right? Okay, so example 3 is very similar to this one. It's just now we're going to change on both sides. What is the obvious thing that is missing? Because these are already factored. We're missing the x over here, so I multiply by x on the denominator and numerator. Are they the same now? No, we're still missing a factor. Which side is missing a factor?
9. The 3.
The 3 is. Can I multiply by a factor to get 9? Yes, I can multiply by 3. But what I do to the bottom, I do to the top. So now what's my common denominator? 9x. So we're on step 3. Combine our numerators. X times 4 is 1 times 3 is, so plus, because we're adding now, 3. And then step 4 says factor if possible. Can you factor your numerator? No, then that's it.
Wait, how do you get 9?
Because 3 times 3 is the 9. And then this side was missing the x.
But I thought you would multiply 9 and 3.
No, I multiplied 3 and 3 to give me 9. Because I already had a 3 down here, right? So I was missing a factor of 3, so that way I could get 9. If you multiply by each other, you're making it bigger for no reason. All right, moving on. Example 4. So step 1, factor denominators. Are the denominators written in factored form? No. And you want them factored because can you tell me right now what's missing to be the same? It's hard to tell unless it's in factored form. So then I could use my shortcut again because my a is 1. So use a shortcut. A times c is 10. B value is 7. 2 and 5 would work. So I would have what as my factors? Doesn't matter the order we write it in? No, it does not. Okay, so now let's go to step 2. We compare the denominators. Why is the x plus 5 factored? There's no common factors and there's no exponents, so you can't change that one. But on step 2, we're comparing. What's already the same? So do I need to multiply by another x plus 5? What's missing to be the same? The x plus 2. So I only need an x plus 2 on the right side. So I put an x plus 2 on the bottom, but if I'm changing the denominator, I also change the numerator. Okay, questions right now?
It's always going to be like that.
What?
Like, you have one part of the x, not the other x.
No, not always, because like one like this where we have to multiply by each other, like if they're not sharing anything, which we'll see on the back side, probably not today. But you want to look to see if they share something so you don't make it harder on yourself. All right, so then now we're on step 3. I have my common denominator, which is x plus 2 times x plus 5. But step 3 says we need to do what? Combine the numerators. So then we have 5x we can bring down. And we're adding 4 times this. Can I just add it if there's parentheses like that?
No.
What should I do? Distribute it out. 4 times x is, so I'm adding 4x. 4 times 2 is, so I'm adding 8. Is my numerator fully combined as it can be? We can add our x's. 5x plus 4x is 9x. So we get 9x plus 8 over x plus 2 times x plus 5. All right, and step 4 says, what's up?
Where does the 8 come from?
From 4 times the 2. Because we're multiplying 4 times x plus 2. We brought in 4 times x is 4x. 4 times 2 is 8.
Oh.
Because it's attached, you have to multiply that 4 in with distribution. Okay, so step 4 says factor the numerator. Can we factor 9x plus 8? No, there's no common factors. So nothing cancels. We are done. All right, last one, and then we'll pack up for the day. And we'll do the backside tomorrow. Okay, the denominator is factored.
No.
What does this look like, though?
Ooh, you
Difference of squares. We can use our difference of square rule. So if I square root x squared, because my GCF's 1, what's my a value? 1x. If I square root 16, what's my b value? Huh? 4. So then using the difference of squares rule, we know it's a plus b, which is x plus 4 times a minus b. And there's your factors. So let's go replace it. Cross that off. We put the factors here. I never said pack yet. It's 1:09. We got 1 minute and then I'll let you pack. Keep going. Okay, what's missing then? Step 2 says find the missing factor. Okay, so then this side needs the x minus 4 on the denominator and numerator. So now we got our common denominator. X plus 4 times x minus 4, and we need to combine the numerators. So bring down your 16, and we're adding, so let's distribute that 2 in. 2 times x, so plus 2x. 2 times negative 4. So when I add a negative, what would I write? Negative 8. Is it fully combined? What's 16 minus 8? So we get 2x plus 8 over that. And step 4, oh, dang it, minus. Sorry, that's minus sign. On step 4, it says factor if possible. Can you factor the numerator? What can you take out? A 2. So we take out a 2, and what would be your leftover? So does it simplify? What common factor can I divide out? And now we're done. 2 over x minus 4. Not that bad, right? It's pretty similar to multiplying and dividing. All right. Go ahead and pack.